My name is Jay, and I'm a professor of civil engineering at Rutgers University, and today gonna present on behalf of the researchers at Rutgers talk about dynamic digital twin for secure and smart civic spaces. So let me get started with the project here, and so I can start with some definition about what is digital twin here, because everybody hears this term a lot these days. And so digital twin, according to the National Academy of Engineering, is about using modeling and simulation to create a virtual representation of physical counterparts. And that's not the only part of it. And the second part is really looking at establishing the bidirectional interaction between the virtual and the physical environment to enable feedback and optimal decision making over there. So what is digital twin for in homeland security enterprise, particularly in our research here, looking at a vast number of soft targets and the cloud places over there. So when we started this, and we noticed the state of art and some gaps, and we often encounter element is we see the digital twin creation methods, they're often not tailored to and not scalable to the larger number of soft targets and the crowded places over there. For example, when we're doing the digital twin for a building, the security features are not necessarily explicitly included, like the doors, door open and the door bars on it, locks, all these different things, and the cameras, locations, all the different things over there. And the second thing, second element is because since these soft targets and cloud places are often not closed systems, not less controlled, we often see a lot of the dynamic elements here, clouds and temporary objects like barriers put up over there. Those are not easy to be updated in the current digital twin practices over there. And but we don't do that, and it reduces the fidelity of digital environments over there. So we really need a more dynamic method of updating these changes efficiently. And often also there is a challenge. Basically, we use digital twin to do nowcasting, and we have seen a lot of applications using digital twin to do what-if analysis for long-range planning. But real challenge when it goes down, if you compress the time to a few minutes, few hours ahead of events, that's the real challenge happens. So that's called nowcasting. It commonly termed used in weather forecasting. Look at events several minutes or even just hour before the events here. Lastly, we also notice when a digital twin is built, is often living in on computer. The user interacts through mouse clicks on a computer, and the limited interaction with the digital twin. So we really need at looking at the teaming part of that, the users, operators, and the digital twin, how we can use more dynamically the operating interacting with each other here. So we look at basically in RE2, that is my project here. We look at 4 objectives here. First, we want to develop a scalable digital twin creation method for these STCPs here. And we look at how we can update the dynamic content more efficiently. So that leads down to mostly into we call cross-modality data registration from heterogeneous sensors to update dynamic contents here. Then we're also looking at can we do data assimilation to support nowcasting here. Lisa has a clear collaboration with the cloud simulation models, which we talked about already in RD4. And also, I think after my talk, going to be RD3 here. And lastly, and not least is look at how the users, operators, and the agents in the digital twin in the physical world can collaborate, use the digital twins. So that includes dynamic interaction between a digital twin and the users. So that is also my objective here. We look at AI and meditative methods here to enhance that. So to realize these objectives here, we propose 7 research tasks here. I'm not going to read it then, but these are tasks almost shows almost like a loader map, goes 7 research tasks. I mean squarely to think corresponds to some of the objectives here. And while we're doing these research tasks here, so we leverage a large, quite a few venues we have access to, which is I think Rock's Living Laboratory, which includes a football stadium and many school buildings, a museum at Rutgers. And we also collaborate with New Jersey Transit extensively. We look at the Hoboken terminal, which already have a digital twin being built. And right now we look into the Secaucus Junction here, which is quite interesting because it is a critical station leads into MetLife Stadium, and MetLife is going to host 8 games in, I think, 2026 at the FIFA World Cup. and including the finals over there. So that's our venue to validate and testing our methods, and also draws a lot of inspirations from the. So in the first task here, and we really look at since the building has been digitized using a lot of different methods, but these methods not necessarily consider the security-related architectural features here. So we're looking at ways to digitize the security features here. So we look at the AI-based methods that can automatically detect and localize the security features, and we combine a comprehensive list of these features, and we use using AI-based methods, more specifically the segment anything method, to digitize these features. So in this way, this method complements the current method used in the traditional applications over there. And to further accelerate the mapping of the building elements in a digital twin creation, we also developed a quadruped-based building interior mapping system. It can map the indoor environment in real time, and we also run this method in real time on top of this robotic platform, so we can realize near real-time detection and localization building security features, and also near real-time detection of changes in the scene. So we can use the pushback updating the first digital created over there. In this way, we can increase the dynamic elements in the system here. So then we also, one of the things is looking at the cross-modality data registration here, make it more dynamic. And a typical application is look at a video surveillance system from top left here. We look at how do we register the point cloud, the surveillance video feeds with our facility model, so we can realize localized surveillance video feeds. So we can bring them, semantically and spatially aware the video feeds, then we combine them, and which allows to the localized detect clouds and updating in the virtual environment simultaneously. You can see the bottom right corner. Compared to traditional video interface, we can spatially localize all these video feeds here. This right corner also shows a fusion of different video cameras, so you can cross look at one top, you go down, look at different cloud locations over there. Then the next element we look into is really like how we can increase agent collaboration between different users, operators over there. On this example here, we look at a mobile agent in a football game. I think let's you say with rocket game, and the operator can communicate with this platform verbally through large language model, and the robot can break down this tasks into computer vision tasks, navigation tasks, and detecting unattended bags and sending the information back to the digital twin. In this way, we enhance the model of the operator and the mobile agents and the digital twin can work together using the large language models here. So this is really the last piece, and we're still working on is given if you build high fidelity digital twin here, we can use it to feed into the simulation models to simulate a few minutes ahead. So we call nowcasting here, which work with RD3. And we also look at it using the simulation a few minutes ahead to look at how we inform the sensor reconfiguration, maybe inform changes at the facility level to contain the threats here. So at least largely ongoing work. Last not least, and it's the impact. So this loop back to our research objectives. We look at 5 different contributions, looking at the creation methods and registration cross modality methods data, and looking at human digital twin teaming. We look forward to scale up to a lot